Hypothesis testing, z-test for mean, mu, critical value approach. Here's a possible research question. What is the average weight of newborn babies? Nussfield claims that the mean weight of newborn babies is equal to 8 pounds. So someone is asking, what is the average weight of newborn babies? And Nussfield's hypothesis is that the mean weight of newborn babies is equal to 8 pounds. So this hypothesis has to be tested. So Nussfield wants to test that claim. He found the weight of 64 newborn babies, then calculated the mean and standard deviation. So here are the values. So this is the critical value. Remember, this is the critical value approach. So the critical value has to be provided. And you have the mean, 7.4. That's the sample mean, which is 64 from the 64, which is 7.4. And the standard deviation, 2.87. Okay, so step number 1, you have to state a pair of hypotheses. So what we have to do now, we have to convert that worded hypothesis to symbolic form. Okay, because it's a z-test for mean. A z-test for mean, you must convert the worded hypothesis to symbolic form. So the pair of hypotheses in step number 1 must be the HO and the HA. All right, the symbol for mean is mu, and we have 8. So what we need now is the symbol for the equal sign. Okay, the symbol for the equal sign, we can get that in this table. All right, this table here will give us the symbol for the equal sign. Bear in mind, we have the symbols for all what can be said. So for example, if you say less than or equal to in your claim, there's the symbol for less than or equal to. If you say above, there's the symbol for above, and they come in pairs. So as you can see, the HO and the HA have opposite directions, but the HO always carries the equal sign. So we're looking for the symbol for is equal to. So here's the word for is equal to, that's a HO, and here is it, is equal to. So here's the symbol, and the HA now have to be opposite to the HO without the equal sign, so it is not equal. So the pair of hypotheses will be this pair. Mu is equal to and mu is not equal to. Okay, so this is what we put for the pair of hypotheses, and that will be in step number 1. Okay, and since the HO is the claim, because the HO is equal to, that's what Nussfield says, so you can label the HO as the claim here. But the HO don't necessarily have to be claim all the time. It depends on what the person said. So because Nussfield said is equal to, then therefore it is an HO, so the HO is the claim in that case. But if she had said is not equal to, then the not equal to would have been the claim. All right, it depends on what is said. Okay, and this is the table to convert from words to symbols for the z-test for mean. Now step number 2, 3, and 4 is all about the curve. All right, we have to sketch the curve, we have to shade the critical region, and we have to put the critical value on the critical region. So because it's a z-test for mean, it's a bell-shaped curve, a normal curve. All right, the critical region will depend on the HA symbol. Bear in mind, if the HA is pointing to the right, then the critical region is on the right. If the HA is pointing to the left, the critical region is on the left. If the HA is not equal, then it's a two-tail. So in this case, because the HA is not equal, then we have a two-tail test here, and we have to put the critical value in 2 on both on the left and the right side of 0. Okay, so it's a two-tail test. We have 2 critical regions, 2 critical points, and we're going to put the critical value on the critical points. So we have negative 1.96, that will be on the left side of 0, and we have positive 1.96, that will be on the right side of 0, because it's a two-tail z-test and it's a normal curve. Okay, so here are steps 2, 3, and 4. Okay, remember it's a critical value approach, so the critical value has to be on the curve. So we're going to step number 5 now. Step number 5 says that we have to calculate the z-test statistic. All right, here's the formula for the z-test statistic, because it's a critical value approach. So we need the z-test statistic to compare to the critical value. And the 4 values to calculate the z-test statistics will be provided. Okay, the sample mean, the mu, the standard deviation, and n. Okay, these values will be given to you for you to calculate the z-test statistic. And here's the calculation: 7.4 minus 8, because 7.4 is the sample mean, 2.87 divided by the square root of 64, and we get negative 1.67. So that negative 1.67 that we got in step number 5. In step number 6 is to plot that test statistic on the curve. Because remember, again, it's a critical value approach. We have to use the critical value on the curve, and we have to compare the critical value with the test statistic on the curve. Okay, so let us plot the test statistic on the curve. Where can it appropriately be placed? As you can see, negative 1.67 is closer to 0 than negative 1.96. So therefore now, the test statistic appears to have landed in the unshaded region. Okay, the test statistic seems to have landed in the unshaded region. So in that case, we have to be using this now in order to make a decision in step number 7. Okay, step number 7 says, which is decision time. Reject the null if the test statistics is located in the rejection region. So if the test statistics in the rejection region, we have to reject the null. Okay, but if the test statistics is not in the rejection region, if it is in the unshaded region, we do not reject the null. Bear in mind, it's test statistic. Remember, we have to put back the test statistic on the curve. All right, according to where the critical value is, the critical value on the point. Okay, so the test statistic, if it land in the rejection region, then we reject the null. If the test statistic did not land in the rejection region, we do not reject the null. So here's our test statistic. It is not in the rejection region. So for this reason, we are not rejecting the null hypothesis. Bear in mind, you always start with 2, and you have to either reject or you do not reject the null. So the decision is not to reject the null because the test statistics is not in the critical region. So now we're going to step number 8, which is the conclusion time. If the null is in the rejection region, if the null is rejected, okay, if the null is rejected, then the alternative is the conclusion. If the null is not rejected, then the null itself is the conclusion. Bear that in mind. Okay, so what did we do? We did not reject the null. Okay, so therefore the null is the conclusion. All right, since we did not reject the null, okay, which is the claim, okay, so it is the conclusion. Okay, and we have to state it in words. So therefore the mean weight of the newborn babies is equal to 8 pounds based on the data. Okay, so these are the 8 steps for a z-test for mean. First, you state a pair of hypotheses. According to what is said, you convert the worded sentence to symbolic form using the table. Step number 2, 3, and 4. Normal curve, critical region, and you put the critical value on the critical point. Here is a total because of the not equal. So we have 2 critical region. Step number 5, you calculate the test statistic. Okay. And then that test statistic in step number 6, you go and you put it on the critical, on the curve. Okay, so in that case, it landed in the not rejection region, in the blank spot. That's where our test statistics landed. So in step number 7, we do not reject the null. And in step number 8, since we did not reject the null itself is the conclusion. And what the null is saying, the mean is equal to 8. So that is what we have to conclude. In that case, the mean is equal to 8 pounds based on the data.